Okay, for number 5, just kind of reading through it, the height in meters of an object thrown upwards from the ground can be modeled as a function of time. We've seen this before, by the way. It says times in second, h's in meters. It goes on to say it's reasonable because what goes up must come down. Yeah, it's reasonable. Suppose that one model is this one over here. And this is a model. Not terribly accurate, but it's good enough. It's a model. And you may not like the numbers, and I realize that. A lot of people look at this and say, why are you giving me these numbers over here? But it's important you got numbers. You have numbers, you see that. It says h is said to be a function of time. Clearly this is a parabola, and it suggests that you construct a rough graph before answering these questions. Keep in mind that time needs to be positive. I should say non-negative. All right? So what I want to do is, what I've always been doing, axis symmetry. I know they switch the letters around, and that's often confusing. And as I do that, I want to point out this will be t, and this over here is actually going to be h of t. And I want to write down the axis of symmetry. It's going to be t equals. Well, let's see. You got to be careful. It's the coefficient on the linear term, 19.6. Let's see. I'm sorry, minus that. I'm sorry about that. It's minus b over twice a. And what's twice a? It's going to be minus 9.8. Well, that goes in 2 times. All right, I'll write that down. So t, the axis of symmetry is t equals 2. And I'll put this down over here. All right? I want to get the vertex. And yeah, it's problematic. There's no doubt about it. What do I know about the vertex? I know t is 2. I'm going to go up here and plug it in for you, though. h of 2 is going to be 24.5. 19.6 times 2. Well, let's see. 19.6 times 2. 2 times 6 is 12. 2 times 9 is 18. 18 plus 1 is 19. And then 2 times 1 is 2. 2 plus 1 is 3. So what are you going to get? You get 39.2. And again, these are sort of problematic numbers, but let's not worry about that. I'm going to do the next number, and it's going to be minus 4.9 times 2 squared, which is 4. I'll write that down for you. So 4.9 times 4. 4 times 9 is 36. 4 times 4 is 16, and 16 plus 3 is 19. So you get 19.6. I'll write this over here. Wow, that's a lot of arithmetic, isn't it? And let's kind of add it together. And I'm going to, I'll do it on the side. I get 24.5. 39.2. I'll add them together. 5 and 2 is 7. 4 and 9 is 13. And you can get 73.7. Minus 19.6. Let me write that down. 73 point, whoops, I made a mistake there. 73.7 minus 19.6. That's going to be 0.1. That's going to be 6, 13. Let's see, 4, 54.1. That's where the vertex is, way up here. So it's going to be 2, 54.1. And this parabola is opening downward like this. All right, what's the y-intercept going to be? Let's see, it's going to be 24.5. So I'm going to say somewhere over hereabouts. This is where it hits the ground. All right, let's see if we can, maybe answer the questions over here. And the first question, they didn't ask me to graph it. They asked me to factor it. And kind of looking at it, maybe I should have factored it just from the get-go, but you know what? I didn't. I did what they said, graphed it first. And let me just take a look at that. And let me see if I can factor it. All right, so what do you get? You get h of t And I want to recommend the first thing to do is factor out a greatest common factor. I'm going to say it looks like minus 4.9 to me. And then you get t squared. And let's see, 4.9 times, looks like it's going to be minus 4. And then that looks like 5. I'm sorry, it's t. And then it looks like minus 5. Let me just check it. You get minus 4.9 t squared. I do see that. Minus 16 and 3.6, minus 19.6, plus 19.6 looks good. And then I would get, 20 and 4.5. Yeah, 24.5. Looking good. Looking good. What am I going to do over here? I don't know. I'm going to try to factor that now further. And what do you get over here? Minus 4.9 t 5 minus 5 plus 1. I got it factored. Let's look at the grade key, see how we've done. And I'm seeing it. Minus 4.9 t minus 5 t plus 1. Okay? Show that the object hits the ground at 5 seconds. Now, how could I do that? I have to find that it hits the ground. What does that mean? That h of t, or in this case over here, h of 5, would equal 0. Well, what do you get? Let's write this down. You get minus 4.9, I'm using the factored form, times 6, because 5 plus 1 is 6. And what's nice is 5 minus 5 is 0. And what does that give me? It gives me 0. So that's done. I want to point out that this point over here is when t equals 5 seconds. H would equal 0. All right, let's keep going. What's the maximum height of the object? I think I made a mistake in the arithmetic somewhere. I got to see where it is. I don't want to do the whole problem again, but it's going to be at 2. We already figured that the axis symmetry was at 2. And then I think I made a mistake in saying 54.1, and I got to check that out again. And it should be 44.1, but I'll check. Maybe I made a mistake in the arithmetic. Who knows? And we're plugging 2 in, right? So let's take a look at that again. I'm over here, 24.5. 2 times 19.6, that's 38, 39.2. That's good. And 4 times 4.9 is 19. That's going to be 16 and 3. Yeah, 19.6. 24 and 39. Let's see, 50, 63. Oh, there it is, right over here. All right, 30, 40, 50. Yeah, it's 63. My mistake. So this is going to be 44. And I'm glad I caught that error, not in my key, but in my work over here. So yeah, it's 44.1, and we're done. All right, 44.1. Again, I made a mistake in arithmetic up there. Maybe you caught that I was talking, who knows. But again, it's important when you're looking at a key, maybe the key is wrong. Maybe the key is wrong. But anyway, the vertex, 44.1 meters. What does that mean? It goes up. It reaches a peak at 2 seconds. That peak is 44.1 meters high. Then it comes sailing back down to the earth. Then hits the ground at 5 seconds. And we're done. Thank you.